Number 6, compare the radius of a positive ion to the radius of its neutral atom. So here we go back to our ionic radius. Now remember, there are two different trends. One for the positive ion compared to its neutral atom, and one for the negative ion compared to its neutral atom. And we're actually going to be asked about both of those here. But for A, we're comparing the radius of a positive ion to the radius of its neutral atom. The radius of a positive ion is smaller than the radius of its corresponding neutral atom. Smaller. When you lose those electrons, typically you're losing electrons until you revert to a noble gas configuration. That means you're actually getting rid of an entire principal energy level. You're getting rid of an entire N value. And so you're clearly going to get smaller once that happens. B, compare the radius of a negative ion to the radius of its neutral atom. The radius of a negative ion is larger than the radius of its corresponding neutral atom. Because in this sense, without adding any more protons, without adding any more positive charge to the nucleus, there's no increase in nuclear charge. And the reason I bring that up is because that's what's going to attract the negatively charged electrons to pull them in close. But that hasn't changed. There's no change in nuclear charge. But you have increased the number of electrons in the electron cloud. And so all you've allowed them to do is start shielding one another, to repel one another, to force themselves to spread out further away from the nucleus, which functionally makes the radius larger than its neutral atom.